let me start by introducing my panel. First of all, I'm Christine Gonzalez. I am the storage tank queen at Entech Engineering. I know many of the people out there in the audience know me, and whenever there's a formal occasion, I always wear my tiara. And for my panel, as far as the Entech guys go, I've got my colleague, Pat Burke. While he's new to Entech, he's not new to the water industry. So he's our new senior project manager, and he's worked in the water industry for 28 years. My colleague, Rob Horvat, is the regional director of Entech's Pittsburgh office. He has 27 years of experience in water and wastewater engineering and municipal engineering, and this is his third roundtable. Kim Mazur is a senior project manager at Entech, and I've known him for years, and we work on tank projects all the time. Oh, by the way, the Lansdale tank looks gorgeous. I was out there on Tuesday. He has 33 years of experience. And one of the reasons our roundtable panels work so well is because of the variety of viewpoints that we get from our audience. I'm sorry, from our panel. And we love to feature other professionals with whom we work. So Dave Bonkovich, he runs his own leak detection business and has been helping clients for 31 years on his own and 36 years total. Randy Simmons is a field supervisor with Aqua, Pennsylvania out of Sayre, and he works in their Susquehanna division with 7 years of experience in the water industry. And finally, Brennan Kelly, he's a senior principal engineer with Aqua, Pennsylvania, and has 26 years of experience. So thank you so much to my panel for coming out. And as I mentioned, these roundtables, they're all about our audience and what they want to know. So we like to do a couple polls during our roundtables. I'm going to launch one right now, and this will give us a sense of what you guys are dealing with, what your struggles are. So the question is, what do you find difficult about non-revenue water? So it's multiple choice, and you can click on as many as you like, as many as maybe as many that are applicable to you, maybe all of them. So I'll give you another 10, 15 seconds, run through those and click on what looks good. And then I'll release the results and everyone out there will be able to see it. Okay, so I'll give you another 10 seconds and then we'll end the polling. Okay, and let's take a look at these results. And I'll share them with everybody. Okay, so it looks like the number one thing was the adequate leak detection. So Dave, definitely something you can help us with, right? Second biggest one was how to effectively use meters and meter pits. And I apologize, I think I spelled meters wrong. I missed an E. I hate that. But I'm an engineer, so is that a good excuse? And the third one was understanding the AWWA Water Audit Methodology. Okay, so thank you so much to our audience. This is very, very helpful. It lets us know what topics to focus on in addition to answering your questions throughout. So thank you. And one of the things I want to kick it off with is, okay, this, oops. Share my screen again because this is managing non-revenue water and its best practices. So what is non-revenue water? Let's just start right there, because some people in our audience may, be young engineers, and I know my forte is tanks, but not non-revenue water. So Pat, what do you think that, or for you, what's the definition of non-revenue water?
Well, the short answer to that, Christine, is essentially water that was produced, finished water that was produced by the utility that doesn't make it to the customer's taps and therefore doesn't generate revenue. So that's through losses, utilizing the new AWWA terminology. It's apparent losses or real losses. So it's the difference between those losses and the water that was actually produced.
Okay. When I was actually coming up with the topic name for this roundtable, at first I was using unaccounted for water. And then when I Googled it, they're like, oh, they changed the terminology back in like the early 2000s. So Kim, I see you nodding your head. What's the difference, or what happened with the names?
I think they just wanted to tie it to exactly what Pat described there, was water that's not producing revenue. They thought that it was, kind of appropriate, but it's so easy for unaccounted for water to roll off your tongue, though.
Good point. Anyone else want to add? Or Dave, go ahead.
There's actually a third term. Some people classify it as metered ratio, which is, it can be a little more obscure because meter takes some things into consideration, but it doesn't. The non-revenue term is a little more inclusive for all the other components that make it up.
Mm-hmm. Okay. Brennan?
Yeah, the other thing to add too on non-revenue water is it can be water you know about, but you're not making money on. So if you're flushing a hydrant or flushing mains, you can quantify that water. You're not making money on it, but it's non-revenue water, but it's accounted for.
Mm-hmm. Okay.
Also, in plants, we use water for flushing, and certain analyzers use water continuously. So it's not making money, but it's still treated water that you can quantify.
Okay. Anyone else want to add to the definition in any way? Okay, so number one concern with our audience was leak detection. So big question I have is, well, most utilities, do they do this themselves, or do they hire someone like Dave to do it for them? Dave, what do you usually see out there?
I don't know anyone who doesn't do some type of in-house leak detection. Everyone that I've been involved with, even for 15, 20 years, has some type of leak detection equipment and does some type of in-house work. One of the things that we try to incorporate when we get called, and I try to encourage people to do as much in-house as possible. That's taking ownership for the operation of your own system. That's where it all begins. Probably the single most important thing as it relates to non-revenue is establishing some type of system baseline. I mean, you can look at, you always, everybody relies on metering, but you always have a certain component of non-metered issues. You always have a certain component of meter error and things like that. Establishing that baseline, whatever that baseline is, and every system has its own personality. That's the key, and it ties directly into metering, but it's not just metering.
Yeah, great point, Dave.
Yeah, go ahead, Randy.
In my division, we do a combination. My guys are instructed, they have listening devices. They're instructed if they touch a valve, if they touch a hydrant, to listen on it. We also have leak detectors that we put out in the system on a regular basis. And what that does is it narrows things down. So when we call in Dave to do a system survey, he can pinpoint on the areas that we have identified some issues.
And Rob, what do you see out there as far as our clients go? What do they normally do?
Yeah, it's same. Basically, what these guys are saying is, definitely some level of in-house, and then typically when it becomes an issue and they've exhausted their resources, they call in somebody like Dave.
Okay.
So guys like Dave get real busy certain times of year.
What times of year do you get really busy, Dave?
I'm busy year round. It doesn't really slow down. When the weather's good, it gets crazy when in the springtime when everything breaks. But really, I mean, it used to be seasonal, but it's not even seasonal anymore. We do leak detection year round. Wind probably shuts me down from more than any other conditions out there. You start getting some snow accumulation up in the snow belt. That can be an issue.
Okay.
There too, but rain or shine, 90 degrees or nine below, we're out doing work there.
Oh, wow. Okay. Pat?
Yeah, and certainly one of the bigger challenges with leak detection is just locating the mains, especially when you have non-metallic mains. And the sounding that you need to go through in order to pinpoint those leaks in non-metallic mains is very, very difficult, especially for for operators who maybe aren't doing it all the time. That's where someone with some expertise, like Dave has, and that fully calibrated ear is able to pick up the real quiet sounding leak, so to speak, that you find in the non-metallic mains.
So I guess, Dave, part of your success, it's a combination of experience and like knowing, hearing, but also the equipment that you have. Would you say that's true?
There's lots of good equipment out there, and of course some is better than others, but it's not just the equipment. The listening experience is invaluable. The more leaks you hear, you form that mental library that you're always drawing upon. Whether are you hearing something that you've heard 100 times before, or are you hearing something that you only heard a couple of times before? Every year, you'll hit something like one or two leaks that do something odd that you've never seen before. Intermittent sounds, different sounds, and actually, while we're talking about sounds and leak detection, probably the single most important component is getting out when you're able to hear. You can have the past 2 days, beautiful, bright, sunny days, and it was actually windy out there. Wind probably, you can have the prettiest weather in the world, and if the wind's blowing and you can't hear, you're probably compromising your ability to do an effective job. It's and it's relative to the size of the problem you're looking for. I mean, if you're out looking for something big, something sizable, something that's compromising your system, you can certainly do it. I mean, we go out in pretty absurd weather for those types of leaks, but for doing general day in, day out leak detection, you're probably compromising your results if you're going if it's windy outside and you're dealing with different types of background noises that are compromising your ability to hear things clearly.
Interesting. Okay, Brennan.
Yeah, I was just going to add that in Aqua, we do a combination of in-house and external third-party water loss efforts. We just tried Utilis, which is a company that uses satellite data to identify leaks, I guess, via infrared camera.
Mm-hmm.
They can give you an idea where leaks are, and then you send a guy out like Dave to go find them specifically.
Oh, wow.
We piloted that and mixed success. One area worked very well. Another area, I guess maybe the soil conditions or however, maybe leaks don't surface as well and didn't work as well. So,
Mm-hmm.
but,
So it sounds like you're still collecting data on where will it work best?
Yeah.
Okay. Interesting. Kim?
Yeah, just real quick, I know some of our clients, depending on how big the system is, we've actually looked into dividing their system up into 3 or 4 kind of like sections, and then each year they bring in someone like Dave or a professional and do a section a year, and then they do that on a rotating basis. So every 3 years or so, they're re-hitting the same section, and then they work that into their budget, and they kind of work it that way.
Okay. Now I see we've got a couple questions in from our audience, so thank you. Reminder to our attendees, send in your questions through the Q&A, send really hard ones to Rob Horvat. And so first question is, does anyone use a permanent system to monitor for leaks? So is there such thing as a permanent, does this make any sense? A permanent system to monitor for leaks? Brennan?
So at Aqua, we bought a permanent system to try it out. I think it's the 829 program. And it's basically—
What does it mean? What does that mean, a permanent system?
Permanent, it's always out there listening.
Okay.
Listening sounds and trying to identify where a leak's located continuously. So we've heard from American Water, they've tried that successfully, but then they call it lift and shift. So they take those same instruments and move them to other areas. So because a permanent system always sitting there is expensive. So
okay.
Kind of feel like once they identify the leaks, let's keep using it and move it along. So
that's a cool way to use it. Okay.
Yep.
Excellent. Dave?
The permanent systems, commonly referred to as loggers, it's really advanced a lot. They're the radio technology, the ability to communicate with each other. You basically went from single point loggers to correlating loggers with that's web-based and cloud-based, where you can basically they're permanently deployed and anybody can log into the system at any particular time. You can see the noise profile that any particular logger is picking up, and also the adjacent loggers relative to it, and depending on how accurate the loggers are programmed into the online mapping, the correlating loggers will actually give you an idea where that when they start picking up leaks between points, it actually gives you an idea where it's at out there.
Okay. Good. Pat?
And even some of the newer residential meters, the smarter meters have some leak detection capabilities where they are smart enough to be able to pick up flows that really shouldn't be happening. And then when the utility goes back and reads the meter, it'll also send over that code that says something's wrong here. So I know that there's some good newer technologies out there that will help the utility in driving down its non-revenue water.
Mm-hmm. Okay. Rob?
Not necessarily on something as far as a permanent system for listening, but a lot more systems, especially in the last couple of years, I've had a lot more systems going towards zone metering and breaking their system into consumption zones where basically looking at how the water flows through their system. And then, I think there's Dave earlier that mentioned establishing a baseline. You start creating some data sets for how water flows through your system. You start understanding a little bit of that. You can pick up little nuances, and when a leak develops, look at that data and then update the data set and say, okay, what changed? And you can find really helps a lot with leak detection. So
okay, interesting. Brennan?
Yeah, I was going to say we at Aqua created a district metered area where you kind of zone an area and you see how much water goes in, and you compare that to the meters the customers used.
Yeah.
The problem is in big areas like suburban Philadelphia, it's hard to isolate areas like that with keeping air flows available and things like that. So where we did try it, it worked well, but it turns out that was a tight pipe system anyway. So we didn't get a home run with it, but we did try it. So.
Okay. Okay. And I see more questions coming in from our audience. So thank you. Yeah, keep sending them in. This ties in with what we're talking about right now. So another question, what future technology do you see coming? And do you think this will help significantly to improve leak detection? So I think I'll pose that to Dave, since you're out there in the trenches. What do you, anything new coming down the road that you're excited to try?
Some of the permanent based systems, they're actually going to 5G capabilities where it's improving the reliability, improving the functionality, improving the real-time component of it. Actually, backing up a little bit with Rob's comment about zone metering, and I made the comment about establishing a baseline. You have to remember that you might have different seasonal baselines, that your winter baseline is going to be different than your spring, it's going to be different than your summer, and then you're going to transition again in the fall there. So, and it's not like you have to go crazy over it. Just remember that there are going to be seasonal differences in seasonal usage.
Okay, good point. Okay, Pat?
Yeah, we tried a technology a couple of years ago and a couple systems piloted it. Maybe similar. I'm not sure how much, if it's different than what you were trying, Brennan, but essentially it was it was a thermal based system where you tried to, a company went around and drove around with sensors on top of a trucks looking really for differences in temperatures in order to predict where a leak might be occurring, looking for different saturation levels of the soils. Mixed success. It was very costly, and honestly, I couldn't justify doing it again. But hopefully, those types of technologies are improving. And I don't know, Brennan, if you can talk about what you were trying to pilot. I heard that was pretty exciting as well.
Yeah, that was we piloted Utilis, and Utilis buys NASA grade satellite imaging and data to try to do the same thing. Look for cool spots
Mm-hmm.
where they think water, a leak might be. And they give you a map kind of saying, here's the hot areas where you should check for leaks. And they give you a prioritized list. And we found some, it works. It's expensive.
Yeah.
$1,000 effort, So we're kind of thinking right now, if we go forward, we would do it like once every 5 years or something like that. It set the stage for finding leaks thereafter.
Mm-hmm.
Okay. Dave?
Instead of using satellite-based, I've heard of some companies trying to use drone-based infrared. I don't know how successful that is. I suppose it could work. I mean, if using infrared, looking for a temperature differential. I'm still out on it. I mean, I could see in some extreme situations, and even some seasonal effectiveness, depending on what the outside temperature is, the air temperature is, the ground temperature is versus the groundwater, and looking for a hotspot difference with infrared. I could see some effectiveness there based on the season as well.
Okay. Rob?
I'll tell you what, just recently, we were doing some hydraulic modeling, and shout out to Nick O'Halloran in our office, who was the actual one driving that model when he did it. But had two different circumstances in two different systems where we were doing some calibration, doing field calibration with pressures and flows, and punch all that into the hydraulic model to calibrate the model and have the model spit back, hey, you got a problem here. There's probably a pretty sizable leak in this general area. And from that point, we were able to kind of point that to the staff and say, hey, check this area. Something's not quite right there. Not necessarily a permanent system, but we were able to locate some pretty significant leaks through model calibration, which was interesting.
Anyone else have an experience like that with using modeling and then comparing it? Pat, I see you just nodded.
Well, I mean, it's been used, and especially with the advancements even in the models, the accuracy is there. But I've heard of things like that happening where it's remember years ago in a system that I was working on, we had a similar success story where we just couldn't figure out why we couldn't get the model calibrated. It's because there was some significant demand or draw on the system, which was lowering the pressures.
Okay.
Mm-hmm.
Now you guys have mentioned the acoustic for finding leaks, the thermal radar checking temperatures. Any other ways to do it? Any other technology? And I'm assuming the acoustical ways sounds like it's the cheapest way to go, and it's been around the longest. What about that divining rod, or that metal rod thing?
Well, that's for locating the non-metallic mains, and I mean, I've seen some fancy ones out there.
Am I right? Divining rod? Has anyone seen that work successfully?
The brass rods. I've seen that where, again, I could never get the damn things to work for me. But I've seen people. I mean, there was one guy in particular I'm thinking of, an operator in central Pennsylvania who. I don't know how he did it, but he was always able to find non-metallic mains, especially the transite asbestos cement mains. I remember one particular instance where we were trying to locate a transite main for a tie-in, and the contractor was dug down 7 feet, didn't find the main. It was a transite main, and the operators there, it's there. Just keep going. 9.5 feet down, they found it. Right where he put the mark.
Oh my God, that's great. Another question from our audience: are leaks typically the biggest source of non-revenue water, or biggest, I guess, pool of water that's out there, non-revenue water? Randy?
I think it's the biggest part of it.
Okay.
But I think we also need to be mindful of calibrating production meters every year, make sure they're working properly. The other side of it is what Dave touched on a little while ago, was the metered ratio. On the service side, we got to make sure that the zero reads and the missed reads are all taken care of. And if you take care of that stuff, you take care of the leak detection, you're going to see that metered ratio number come together. And that's when your non-revenue water gets better.
Okay. Another, this is a comment from our audience. Rob's remark on the modeling of the hydraulics is the basis of the real-time transient modeling method, which is used in oil pipelines almost exclusively. Are any of you guys aware of that?
I think that's exactly what Rob said.
I also see, a comment from our friend Maureen Coleman. So theft is a huge part of non-revenue water. Can anyone speak to issues and solutions pertaining to the experience of theft in non-revenue water? Ooh, that's a good question. Thank you, Maureen.
We could spend an entire roundtable just telling horror stories of things we found in the bill.
Okay, I'm making a note. We'll do that in the spring. So what have you guys seen out there? Pat.
Yeah, well, they make some mathematical models for it, some what they call the theft algorithms out there sometimes too, which are kind of, utilizing a lot of the meter reading data for individual customers. And because there are times where we all know it, where, sometimes customers help themselves to the plumbing and the metering, and some of them are pretty savvy about it in terms of just removing the meter for a period of time on their own and then putting it back on. But there are some things that various consultants can recommend, and I know Aqua has employed some of those quite a bit and quite effectively over the course of time in running these theft algorithms.
Kim, what are you seeing?
Yeah, I've seen that if you have a large customer base and then you have a good percentage of those customers that are commercial, those companies will have some kind of a meter manager that dedicates some time to managing those accounts, making sure that they don't see any kind of odd consumptions or dips in consumption in those large customers. Because granted, someone takes water at a residential home, that's not going to kill a company that has 50,000 customers. But you get a couple large customers that take 300,000 gallons a day or something like that. Some of these big commercial places, you need to kind of check their accounts regularly. Also make sure that their meters are, being replaced accordingly and things like that.
Okay. Yeah, Dave?
Randy already mentioned metering, and Kim was just talking about it too. About 25 years ago, I did a leak survey at a beach community. Basically, you're going from a summer population of 25, 30,000 people to a winter population of like a couple thousand, something like that. And this particular system had over 250 2-inch or larger meters. And they had this phenomenon where normally if you're dealing with typical meter accuracy, that as your summer usage goes up, your metered ratio improves with it because people are using more water, and so the amount of water being used greatly exceeds whatever you might be using in leakage. And the exact opposite was happening there, and it was because of the meters were oversized, or there were so many oversized meters in that community that they were missing the 2-inch, 3-inch, 4-inch meters were missing low flow situations, and the extreme number of oversized meters in that. And then in the fall, when the town was basically vacant, there was the leakage didn't change that much, but the usage and the usage that was being missed by the meters came way down, and the meter ratio actually improved in the fall, and the non-revenue was tied incredibly to the oversized meters in the system rather than actual leakage itself.
Okay. Kim?
Yeah, to add to that, you know, a lot of companies that have commercial accounts, those buildings will change usage over time. You know, the building might have originally been designed for some kind of a manufacturing system where they needed a 6-inch meter or a 4-inch meter. But as the years go past, that industry left that building and another one moved in, and it could have been just a warehouse now, where all they need is a 1-inch meter. And, you know, to what Dave is saying, you know, the meters at the low flow are not going to record accurately.
Okay.
Yeah.
Is that something, Brennan, that Aqua pays attention to over time to check on those things?
Yeah, I would say theft is not a huge problem for us. I know it is in the city of Philadelphia. It's a big problem. I hear small stories at Aqua about, you know, contractors pulling up the hydrants and helping themselves at hydrants with their tank trucks, things like that. We do have problems with theft, but it's not a big part of our non-revenue water or lost water.
Okay. Okay, interesting. I want to do something a little fun right now. The panel has no idea this is coming up right now. So I want to throw it out there. It's a lightning round. Okay, so we're going to go around the panel. And this question and an idea came in from Steve Wagner in our office. He would like to hear what does a leak sound like? So I'm going to go around the panel and I want to know, what have you heard? So I'll start with you, Dave. Dave, if we were to hear a leak, what make the leak sound?
Sounds, well, it depends if you're listening with a ground
No.
microphone.
I want to hear it. What's it sound like?
Jet airplane. Oh,
No. Make the sound. I want to hear the sound. Go ahead. I don't hear anything.
Figured it out.
Okay, Rob, what's a leak sound like when you've heard it?
It sounds like Dave.
No one's gonna, because I've never heard one. So like, or Kim, what do the leaks sound like? Go ahead, give us your best leak impression. Ooh, okay, and is it constant? A constant sound?
Yeah.
Okay, Pat, what do you hear when you're out there?
Same thing, just this constant hissing, depending upon the size of it too. Really, Dave, you can speak to this more than me, but depending upon the size of it, it's higher or lower pitched.
And so what's the correlation? When it's higher pitch, what's that mean?
Could be even the material.
Go ahead. It's typically the higher pitch. There's my experience have been really the smaller leaks because they make actually a louder sound.
Okay, is that what you've seen, Dave?
that's usually typical. Everyone has to remember when leak noise is created, it's actually created in the water medium itself. It's not created in the pipe. The same way an organ creates music, where the bellows is pushing air through the orifice in the organs and making sound in a church or somewhere wherever. Water leak noise is created the same way. It's generated in the water medium, and then that noise has to be transferred into the pipe and the surrounding soil. So the smaller the orifice, generally the higher pitched noise, which is also generally associated with smaller leaks. Again, you can have a 16-inch pipe with a hairline crack that's putting out a lot of water and still have a high. So, but we're generalizing with the noise. So yeah, generally you're dealing with a smaller orifice and a high pitched noise.
Okay. Randy, when you've heard leaks, what do they sound like? Give me a sound. And Brennan, give me your best leak sound.
You know, I don't listen to leaks. Not my job, but you could ask my wife when I get up at 3 a.m. what one is.
Well, thank you guys for playing along. I appreciate it. I think we've got another comment from our audience. A reminder to the viewers, we're taking questions from you throughout. So use the Q&A button at the bottom center of your screen. This is someone from American Water. James there says, inspecting new construction is key at American Water. we inspect new development and find lots of plumbers turning water on with jumpers for inspections. So working with local code enforcement is key to combat this theft. When he says they have jumpers for inspections, what's that mean? What's a jumper? What's that mean?
Well, my experience of the jumpers are typically the ones that are, the taps that they're making in order to perform the pressure test and order the disinfection, to fill the pipe initially. I'm thinking that might be what's being talked about here. And sometimes, yes, they are left in, and the developer knows where they're at, so they can help themselves. Because they tell the contractors to leave them in.
Okay, Kim, you're nodding your head. Would you agree?
I agree. Yeah.
That's it. Okay, interesting. Randy, have you ever noticed anything like that in your system out there?
I've never noticed it with contractors, but we have found some customers, residential customers that have jumped their meter to gain an advantage.
Interesting. Okay.
People do crazy stuff.
Yeah.
I've seen people just take their meters out and plumb a straight piece of pipe through.
How hard is it to do that?
Not very if you know what you're doing.
Not very if you have long arms and you can reach down.
Yeah.
Oh, that's awful. Interesting. Okay, so do you want back to the first poll question we had asked, and that was to let us know where to focus in. So we spent some time talking about leak detection. The second biggest question was how to use meters and meter pits. Anyone want to throw anything out there in regards to using meters and meter pits? Well, actually, Kim, help me out. I believe we had a client who thought they had a bunch of water loss. Didn't you go out and put meters in pipelines?
I'm trying to remember.
I swear you did. It was like a year ago, because there was I was going to do a Hardy Boys mystery with you on the mysterious water that there's a water loss and they didn't know where it was, and I never found out what the solution was to the mystery.
Oh, that's right. That's right. I think it was up in Schuylkill Haven. We did a bunch of, we put some data loggers out, pressure loggers.
Okay. Okay.
Yeah. And basically we determined, this is not anything to do with leak detection, but the one culprit was a nursing home that redid their interior plumbing with some hot and cold valving that just operated very quickly, and it caused surges in the water system. And it was just basically some of the new hot water, just like kind of like flushing toilets where they have like flushometers that use a lot of water in a short period of time can cause surges. But
okay.
I think back to something that David talked about earlier was with meters is making sure that they're sized correctly and making sure that the owner, a lot of water companies need to make sure that they have regulations that customers need to test their meters on a regular basis, the larger customers, and that those meters are accurate.
Okay. Pat?
I think the advent of the use of meter pits, at the curb lines, I think has been a godsend for managing non-revenue water. The utility can go around and replace every stick of pipe they own in the system, including the company side of the services, and really not put a dent in their non-revenue water if in fact they're dealing with a lot of leakage on the customer side. So that's where the installation of the meter pits, which is at least in Pennsylvania, is from my knowledge and experience is relatively new. I think that's got significant advantages and provides a very, very helpful tool, because if the customer side service is leaking, you put a meter pit in it and they get that first bill, which is going to be a whopper. That's the indication that you got a customer side service leak. Otherwise, unless you're doing, just continuous field leak detection, a lot of times you're not going to find it if those leaks in fact don't surface, which happens a lot in Pennsylvania with the types of soils that we have.
Yep.
A question from our audience, how frequently should meters be replaced? And is there a sequence that should be followed for meter replacement? Who knows stuff about that? Randy, what do you normally do?
We do large meters, everything 2 inch and above every 5 years. And then I believe the smaller meters, the 5/8 and 3/4, are on a 20-year rotation.
Okay.
Sounds about right.
Yep.
Okay. Kim, you're seeing the same thing out there for our clients?
Yeah, and production meters, Randy, are they every year?
We calibrate them every year, yes.
Right.
Yep. Our large meters, we actually replace every 5 years.
Wow, that's great.
Okay. Rob, you seeing the same sort of thing for our clients?
Where funding permits, yes. What replacing large meters every 5 years is a struggle for some smaller systems. But
Okay.
yeah, generally, at least taking an eye on them, keeping a good, keeping good metrics on them, seeing what they're reading and looking for changes over time. Looking for those meters to slow down over time.
Okay. Okay. Dave?
Just making a comment about meter accuracy and typically everybody expects the meter accuracy to degrade over time. Every once in a while, you'll see an extreme case, and it probably has more to do with the meter installation parameters rather than the age of the meter. There's a certain guideline, the length of the straight pipe before and after the meter, so it doesn't create turbulence going into the meter chamber. I've seen some extreme cases, even on 4-inch and 6-inch, that were way over recording. And it wasn't related to the accuracy of the meter. It was because of the installation, that there were fittings and bends that were either too close before or after the meter that was creating turbulence, and that was actually throwing up the accuracy itself.
Interesting. Okay. Cool. Okay. We have another poll I wanted to release to the audience. Once again, this will help us to continue our discussion and better understand what you guys are dealing with. So posing this to the audience, and do you know what? I'll allow the panelists to vote if you guys want to chime in. So our next question is, what do you consider to be an acceptable level of unaccounted for water, UAW? So I'll give you about 10 seconds to chime in on what looks good to you. Okay. Looks like we've got just about everyone who voted. So I will end the polling and share the results. So it looks like an acceptable level of unaccounted for water, less than 20%, that got the most, less than 30%, 21%, and then not applicable. So that's an interesting response from 5 different people there. So I'm gonna pose this question to our panel. Is that actually a good, is under 20% a good number, or like, what do you guys think? Who wants to chime in on that? Brennan, start with you.
Well, I think the 20% is a long-standing metric that maybe DEP had in their guidelines, and I know we're held to it in some of our systems. Even now, the Public Utility Commission asks us to get certain systems down below 20%. If you talk to people in AWWA now, that metric of percentage is not actionable. Doesn't really mean a lot. You can have a small system of, say, 100 customers, and their water loss is above 30%, but the volume of that water is very low. The value is very low. So the new way to go, they're trying to get metrics that are cost-based metrics. So you're making smart decisions about where you're spending your money to. So just the percentage is not always a very good way to go.
Interesting. Pat.
That's a dirty word.
What's a dirty word?
I don't count it for water as a percentage anymore. It's just And I always hated chasing that down, especially when you have a smaller system. 20% might not mean anything. Plus, the way it's calculated, I've always had issues with it. I agree with Brennan entirely. I just think that the new methodology that's out there with the M36 manual for AWWA, in which you're actually quantifying and costing the losses. I just think it's a much more effective way of managing non-revenue water, utilizing that going through the audit, as opposed to just the old school way of doing the unaccounted for water percentage. The problem that you run into though is, trying to figure out, well, what metric am I supposed to chase using the AWWA methodology? 20%. If somebody says, well, I'm losing 20% of my water. Well, that's something tangible that you can actually, a lot of people can envision, and it translates well. But when you're trying to transition over to the AWWA M36 methodology, it's a little bit more abstract, in my opinion. But again, it gives a much better picture. It's a much deeper dive. It forces the utilities to look at all aspects of their operation, including their billing accuracy. I just think it's a much more valuable tool and the way to go into the future.
Kim, you have that manual, don't you?
Yeah.
AWWA M36. How do you use it, Kim?
In just putting together the audits, when I started the AWW audit, I was going into this is years ago now, systems that never really used the unaccounted for water system, and it's interesting because I think it makes you take a look at all the details of your operations, like Pat said, and I think you need to focus on exactly how water is recorded and research in detail. A lot of operators are kind of like, well, that's the way we've always done it. So I think you have to look into the details of how they read their meters. The other big meter ratio issue that, Pat and Dave and Randy alluded to was some of these smaller systems, how do they read their meters? And are they just reading quarterly? Or do they have, I know some customers have kind of a billing cycle. So it may take 2 weeks for them to read their customer meters, where then they go out and they read their source meters in less than an hour. So that difference between what's passed through the source meter compared to all the other meters in the system, the customer meters that are being read, that all needs to be accounted for and kind of, back calculated so that those two numbers align. Does that make sense?
Yeah. Rob?
Dang,
Do you
what I wanted to say was, a lot of water allocation permits have that language written into them. And again, a lot of these allocation permits are older, but even some of the newer ones are still writing this 20% in. So I think we're talking about two different things. We're talking about AWWA and what they're saying and what they're recommending. And I think it's going to take some time for the regulatory community to catch up. So it is interesting. I actually have a system has a consent order that includes that 20%. They have the 20% unaccounted written into a consent order. So
interesting. Okay.
Yeah, and
Dave?
Everybody always throws that percent at you, and the very first question out of my mouth is, how big of a leak do you have in either gallons per minute or gallons per day? That's what I'm dealing with is hard numbers. I need to know what I'm looking for, whether we're doing a system survey or doing some type of emergency leak detection.
Okay.
And even a lot of times, and Brennan alluded to cost and everything. I do apartment complexes, and my bill is double or triple, and I say, I know you're concerned about the money. The money means absolutely nothing. I need to quantify the size of the leak so I know what I'm looking for out there.
Pat?
Actually, what I wanted to do is I know Brennan, I know you eat, drink, and sleep this methodology. You use it quite a bit that I can recall. What's your take on the use of the two the audit versus the unaccounted for water?
Yeah, I would say that the audit gives you better metrics to look at year after year for your system, specific to your system, like gallons of loss per day per mile of main. If you have a big system with a lot of main, gallons per day loss per number of customers or per customer. Those sort of metrics I think are stronger and more actionable for your system over time. They're not really meant for you to compare yourself to other systems necessarily. It's it's to help you be a good steward of the water you're in charge of. So to me,
okay, so there's other metrics that you guys use then.
Yeah, and we try to use the dollar value. How much money losing per day or year?
Okay.
How much it's going to cost us to go fix that, right? Because Dave's not cheap, right? So,
but he's worth every penny.
That's right.
Right. And the other struggle here in Pennsylvania, we're a very water-rich state, so a lot of these things are stronger felt in maybe Texas or California, but so.
Good point. Yeah, you're right. Randy?
I had a discussion with my DEP sanitarian last week, and he explained to me that DEP, all they care about is unaccounted for water. They don't care about non-revenue water. They want to know, how much water we're pumping and how much water we're accounting for. And then I send Brennan my non-revenue water report every month. So there's from Aqua, we're doing non-revenue water. DEP wants to see it unaccounted for water. It's kind of a balancing act here.
Which one do you think helps you better understand your system, Randy?
I actually like the unaccounted for water better because, I understand on the non-revenue report that I send in, I put down how much we flush from hydrants every month, but that doesn't change that percentage that everybody hates. When we do unaccounted for water, that percentage drops.
Okay.
And maybe I'm wrong. Maybe I'm looking at it wrong. I don't know.
Dave?
I just wanted to throw a quick figure out, and I just ran this off the top of my head. At a production cost of $1 per 1,000 gallons, every 20,000 gallons of leakage costs you annualized $7,300. 20,000 gallons a day. That's a fat pencil-sized hole in a water pipe. A quarter-inch hole at 60 pounds pressure will do 15,000 a day. Now, granted, not every leak leaks for a year. So, there's always that question, well, how long was this leaking before we found it? How long would it have continued to leak? But, the bottom line is even a relatively modest production cost of $1 per 1,000, that leak is still costing you quite a bit of money.
Good point. Okay, do you know what? We have a few more questions that have come in from our audience. Some of them going back to some past topics, but are there any Are there any regulations proposed for leak detection or non-revenue water? Anyone know of anything?
I have never heard of any regulations.
Other than that, again, that 20% that you do see in DEP design standards, and even with the PUC. There's still that's what I'm used to seeing. Again, I know that there still is efforts being made to try to refocus from the unaccounted for water, like Randy was saying, towards something more along the lines of the methodology. But right now, as far as I know, it's still most of the regulations, I believe, in the state are geared towards the 20% unaccounted for water.
Okay. Yeah. I see a comment just came in from our audience. Some states out west do require annual water audits.
Yep.
Okay. Brennan?
I was going to say, I think like Kim's example of a consent order, they You need to get below 20%. They'll say that. They don't say how to get there or what you need to do. You to go out and, try to find ways to get it down. So they don't really dictate a water detection system you got to use or apply. You just say get below 20. So.
Okay. Okay, excellent. A comment from our audience. This is back from James with American Water. We test our top 5 large customers in every district yearly to stay ahead of failing meters. Sounds like it's a great way to do it and stay on top of things there. Another question from the audience. Is it better to replace meters with in-house crews or via contractors? So Randy, what do you guys do?
We do everything in-house.
Okay.
I mean, unless it's an enormous meter change, throughout the system, but annually when we do large meters, we do everything in-house.
Okay. Rob, what do you see for our clients?
That's consistent with what I see elsewhere too.
Okay. Okay. So it's pretty easy to do then, it sounds like.
Depends on the size.
Okay, excellent. And there's another question from the audience. What is the maximum percentage a master meter can be off? Anyone
That's
have
a
any
good
idea?
question. I don't know how to answer that really. Because each
Kim?
different
Kim, go
types.
I do know that if you have a contractor or sub-consultant come in and test the meter, someone who's been certified to test the meter, they'll have those limits, and they'll indicate on their report form if they feel the meter is too far out of compliance. They'll list that. They'll know the compliance at different flow rates for that size of meter, and they'll inform you that they feel that it's out of compliance.
Okay. Pat, was there anything else?
Now again, the different meter manufacturers will list their accuracies right on there, and it varies between the different types of meters, the turbine meters versus the mag meters.
Okay. Dave, what do you see out there?
I just had a question for Kim. And when they do meter testing and calibration, Kim, don't they actually flow test it at a low rate, the medium rate, and the high rate, and they give the tolerances for all three. So it's not just it's how's the meter performing for low flow, for typical flow, and then for high flow conditions too.
That's correct. Yeah.
Okay. Another comment from our audience. California and Georgia have regulations and they suspect it's just a matter of time until the other states get them as well. Granted, but I mean, we are water rich here in Pennsylvania. So I always feel like we're so lucky, like don't move. Well, unless you like a challenge. Rob, were you gonna say something?
Yeah, I have heard grumblings or rumors that they're trying to move toward some type of a fee based upon what your withdrawal is from your source and whether it's a percentage or however they determine it, but some type of a surcharge for what you're pulling out, what you're withdrawing in comparison with what you're actually using, to try to, I guess, I don't know, to discourage waste or whatever it is. But I've heard rumors of it, but I haven't heard anything firm.
Okay. I see a comment from our friend James with American Water, who I believe was talking about the master meter, how far it can be off. He suggests 2.5% plus or minus, or I'm sorry, 2.5% plus or minus. So thank you, James. Thank you, audience, for keep sending questions in. This is really cool. Another question: how would your operations or actions change if we were not in a water-rich region? And what? So I'll pose that question to our panel. I mean, we have it pretty easy when you have lots and lots of water. And I mean, do they, with their unaccounted for water, do they have to have like a lot lower percentages or do you guys know in regions like California, Arizona, New Mexico? Anyone know?
I think out in California, they tend to use the fixed systems a lot more out there. Your extensive logger systems where you might have systems that have 40,000, 50,000 loggers deployed where they're cloud-based in real time, where you can pull up a computer screen and you can see what's happening there. So yeah, the shortage goes along with increased management awareness of that issue.
Mhm.
Yeah.
Any other comments on that question? It's sort of fun to think about, but nothing we really have to think about normally. So it's like you're putting your mind outside the normal parameters of what we deal with here.
I think there's even a difference in your philosophy and how you approach leak detection. And again, for better or worse, I think the system owns their own source and their own production facility versus whether they're a reseller. I think the resellers are much more attuned and much more proactive and aggressive in regard to leak detection because they're purchasing from another supplier, buying and reselling.
Okay. Okay, another comment from our audience. AWWA has set upper and lower rates for meter accuracy, and it's according to the meter technology and in the meter standard. So thank you for sharing that information. There were a few topics that I want to make sure we have a few minutes to speak about before we wrap things up here. So one of them was in regards to finding funding for leak detection and taking care of this sort of thing. Reminder, Entech will be hosting a roundtable in 2 weeks on finding funding for your projects. But Rob, I know you gave a talk at the Pennsylvania AWWA conference about 2 years ago, and it was about 3 different projects in regards to, I think it was replacement of mains, relining of a storage tank that had leaks. And tell us a little bit about that talk and those projects that you went through, and what happened with the money with that.
And you're going to ask me to remember that.
No. Well, I mean, I can say it, but and you don't need like.
I don't remember what the money was, but there were. I think we highlighted 3 projects, and none of those projects were intended to be like huge, like unaccounted or trying to reduce leakage. It was just simply these projects needed to be done. They'd been deferred for a long time for many reasons. The one was a reservoir. It was a membrane. It was a floating membrane cover on a concrete tile reservoir, and we ended up sinking the cover, repurposing it as a liner, and then putting a new floating cover on top of it. In that case, I want to say that the production dropped 35% from the plant overnight, and all of the wetlands up in the area of the reservoir all dried up within a matter of weeks. The second one was a project up north. It was actually an Aqua project. It was a state road. It was a recent acquisition. They got a call from PennDOT that, hey, we're going to pave the road. That'd be great if you could replace your main. When are you going to do that? The end of next month. So they fast tracked the project and replaced basically the spine of their system right down the middle of a state route. Again, very, very difficult conditions, thick concrete asphalt, but able to partner with PennDOT and get it done. And in that case, I don't remember what it was, but it was a huge number. 20% right off the top of production, 200,000 gallons a day, something to that effect. And again, a project that it was a recent acquisition. The previous owners didn't have a whole lot of money. It was old cast pipe. It was tough to get at, and it was in the middle, right down the middle of the state route. So they got into that and took care of that, and immediately just dropped their leakage significantly. I want to say it actually may have taken their percentage down below 10% for a period of time right after that project was done. And then the third one was another similar circumstance. It was right through a state route, right through the middle of a college campus. Again, really, really difficult conditions to get at. And PennDOT was actually going to lower the road elevation, so it was going to reduce cover to like 2.5 feet. So they had to go through there and do that. Now that was really sandy soil, alluvial soil. Had no idea they had any leaks at all in there. But again, they finished the project and immediate went from, I want to say they were putting out, the plant was probably putting out a little over 8 million. And since they finished that project, they're averaging closer to 7 million a day now. So, 1 million gallons a day in that stretch of main. Now that was probably about a half a mile, 3/4 of a mile of main on a straight route. But again, really difficult to get to. Sandy soils, had no idea it was leaking like that. And do the project when the opportunity presented itself. And, all three of those projects really had a huge impact on reducing the level of production they needed to put out.
And what just blew my mind is it's like to find money for projects and potential leak areas. It's hard to find the funding for it, but if you can, like those projects essentially paid for themselves in a few years, right, Rob?
Yeah.
But you can't, it's a struggle though. You can't go into it saying, we guarantee you will decrease usage or production at your plant and minimize this and that. You don't know, but so often it is a side effect, a pleasant side effect where you do end up saving money by spending money. Has anyone else on the panel seen anything like that, or gone into a project hoping for it or knowing you get something like that?
Sure,
Okay.
some of the ones that Rob had mentioned, they definitely can pay for themselves. Is using some of the statistics that David brought up earlier with the quantity of water that you lose and how much that it's inevitable that it would definitely pay for itself over time.
Okay. Another thing we wanted to pose to the panel was pressure management. So pressure management, I guess, of your water system. Who here has, or Randy, have you decreased pressure over time as your mains have gotten older? What do you do as far as pressure management to help minimize water loss?
We really haven't done anything up here since I've been here.
Okay.
We just kind of let the pumps go and the pressure is what it is.
Okay.
Mm-hmm.
Kim, what have you seen with our clients?
In Jim Thorpe, this is a number of years ago, some of the older communities, they had high pressures in town. They just basically had one large distribution system, and that's just the way it was designed. They were in hilly terrain, and so at the end of the system, if they had 125, 130 pounds, that's the way it was. And we went in and broke their system up into actually 3 separate pressure zones, more manageable pressure, and because of that, we saw a reduction in leak in unaccounted for water by reducing the pressure, breaking their system down into 3 pressure zones.
Okay, Brennan?
Yeah, I mean, it's a great idea. It's not always so easy to, put in effect. That district metered area I was telling you about, we were dropping pressure at night there to see if we could quantify less leakage, but that system was so tight anyway, it didn't really a lot. But yeah, again, it's like you have to be able to provide fire flow to people at night. You also got to fill your tanks typically at night, so it's not always so easy to.
That's exactly right. Yeah.
Dave?
Pressure relative to leak detection, even and this is going to sound pretty dramatic, but even looking at a gravity system, every 10 feet of water column is equivalent to what, 4.32 pounds, Pat? Something like that. 4 pounds doesn't seem like a lot, 10 feet of elevation, but we deal with it all the time out at Aqua's Treasure Lake system, where you deal with the 10, 20 foot elevation change in the tank. Non-metallic systems are incredibly dynamic when it comes to elevation changes in the tanks, where that plastic pipe that's in the ground, whether it's plastic main, especially old plastic main, or plastic services, if you're dealing with that, you take 10 feet, 20 feet of column pressure off, the system relaxes. And then as soon as you start building that pressure back up, and that tank recovers 10 feet and then 15 feet, you have to start watching it. I can't tell you how many times, we've done leak detection on systems like that, and everything's great for 2 weeks or a week or a couple days. I'm dealing with that locally right now. on a smaller system, less than 30 miles. And everything's going haywire now. Basically, they were good for 2 days, and then everything let loose. They gained about, and it wasn't even that dramatic. They gained about 5-6 feet in the tank, and everything's popping right now on a non-metallic system. So the plastic and the non-metallic systems are probably affected tremendously more than a system such as yours, Randy. Up there where you're dealing, primarily, ductile and cast iron and everything. You don't see that dynamic effect when you see the tank levels drop.
Rob, did you have a comment?
No, I didn't.
No, okay. I see we're up at 3:15 right now. We've answered all the questions from our audience. So what I'd like to do is wrap things up and did the lightning round. You guys did great with your impressions of a leak. So if you enjoyed today's roundtable, we're doing these every 2 weeks, and we've got 3 more planned for the rest of 2020, and then plan on doing them into 2021. The next one I've mentioned several times, in 2 weeks, show me the money, finding funding for your projects. So we've got another one on I&I, so that's the inflow and infiltration on the wastewater side. And then this one's already got, I think, more than 20 people signed up to attend. Beer with an engineer, old timer share what I tell my 21-year-old self. So I am very much looking forward to that. Actually, Joe Thurwanger from Aqua is planning on being on our panel. So if these look interesting and you want to sign up for more of them or see videos of past roundtables, go to our website, entech.com. And at the bottom right, you'll see a blurb for the roundtable recast, and that's where you can catch all this information. So this was fascinating. So huge thank you to my panel, the folks at Entech, Pat Burke, Rob Horvat, Kim Mazur. Thank you so much to our industry friends, Dave Bonkovich, and with Aqua, Randy Simmons and Brennan Kelly. And to our viewers out there, if you're interested in getting a PDH certificate or operator CEH, please send me an email and I'll make sure you get one of those. And so finally, in conclusion, as far as my panel goes, do you guys have any other words of wisdom or anything that you didn't get a chance to say or talk about? Anybody? Kim?
One of the things that I've noticed that a lot of operators used to help them in-house for leak detections is their SCADA system. If they have a SCADA system that has trending lines for their storage tanks or their pump stations, and if they are in tune to it, they'll be able to get a good idea if they have a leak in the system or not by watching the trend lines on their SCADA.
I can't believe you just said that. You're taking me back to 1990. I'm a co-op from Drexel working at, Philadelphia Suburban at the time in Bryn Mawr. And I was in charge of watching the SCADA system and seeing the tank levels. And then one day it just starts dropping. Like, that's weird. And Don Manuel was there and Al D.R. Cole. And they're like, oh my God, the big inch. Like the 36-inch main had a leak, and you could tell it because the water tank levels were lowering. So very good point. I didn't realize I was part of the leak detection force right there. Dave, did you have something?
Yeah, something that wasn't touched on, but I was going to throw this out to the group, and it ties into metering and rates. It's actually what I call an inverted rate scale. Typically, your billing is set up so you have your base rate for X number of gallons, and this isn't tied into leak detection, but it's tied into system management. You have your base rate for X number of gallons, and then a customer might be charged for over usage or something like that. And many years ago, probably 25, 30 years ago, a really good friend of mine who owns several water systems, he applied and got the first inverted rate scale in the state. And his reasoning was that it's the heavy user, the abusive user, that taxes the system. Most of my work is on smaller, volume-wise, day-wise. I do a tremendous amount of work on small to medium-sized systems, where you can have even one residential user who is careless with watering and running water, he can actually compromise that system's ability to provide continued, sustained product to the rest of the system. And his philosophy was, instead of giving the more water they use, instead of giving them a discount, you penalize them, because they are the ones who are forcing you to procure the additional well, the additional sourcing and everything to make sure that you have water for the rest of the community. And it's not something typically thrown out there, but I'll throw this out to everybody who's listening out there. Don't write that off. I mean, 34 counties are under drought contingency right now. I just got a call this morning from someone. Their water table is four feet below and dropping out there, and they're sustaining, but they're actually worried about it if they don't get some kind of relief. And this ties in exactly to what we're talking about there. It's the high abusive user who really should foot the bill if he's not being responsible with the amount of water that he's using out there. And the number one way to correct that is through an inverted rate scale, and you set it up in your billing system.
Interesting. Thank you, Dave. Any other comments from our panel before we sign off? Okay, so huge thank you to our audience for joining in. Always a pleasure getting your comments, your questions, and your ideas and thoughts and even solutions. So thank you for taking part. Huge thank you to my panel. And the way I always end these roundtables is magical things happen when you bring together passionate people. And you guys are all clearly passionate about water loss and unaccounted for water. So thank you. Thank you so much. And we'll see you soon. Bye, everybody.
Thanks, Christine.
Bye.
Thank you.